afternoon, ladies and gents. Hopefully everybody's hanging in there okay at the end of the graveyard shift now. So we'll try and keep this moving along. I'm here representing Saint-Gobain. So we're construction products manufacturers, and three companies: Gyprock, and Weber, which you probably know quite well. We'll be reiterating a lot of what's been covered. By Bill and indeed by Kevin earlier on. It's the same message coming through. It's all about quality and integration. It's the joined up thinking that we need to achieve successful results on a project. We've seen this carried out quite well on pass-fast projects in the past, but really now the regulations are fast approaching that same standard. So we need that level of integration throughout the team, and that's mostly about information and communication. So we're just going to take a quick look at a recap on TGDL 2011. The real targets, as Bill mentioned earlier on, the building fabric, vapor control and thermal bridging, and then take a look at some practical solutions and this integrated support which is necessary to get an effective result. So technical support, upskilling and quality assurance. This is just a quick slide, gives you an overview of the 2011 regulations. Now, we're all still, as an industry, adjusting to 2007, or at least I feel that's where the industry has been for the last while. What we saw in 2007 was not so much a big change in the individual backstops, but the introduction of the 40% overall improvement, the introduction of a renewables requirement, and the introduction of airtightness as a basic standard. And between those two new things, really, the renewables and the airtightness, we already pushed up quite close to where we needed to be to achieve the 40% improvement, especially when a little bit of attention to thermal bridging was involved. What we now have to 2011 is an additional 20% overall improvement, and this gets increasingly challenging because the backstops, although they have been improved, aren't really where they need to be to achieve the overall target. And this is very much what Bill has said. So you can see there, these are the backstop U values that are shown on that slide, but the real targets, the U values that are really required are between 17 and 40% lower again than that. So, you know, we're used as an industry to looking to Part L and saying, okay, I'll comply with what it tells me are the backstops, and that will get me there. And that's not the case anymore. And it really important now that deep assessment is carried out at design stage before you go for planning or anything, or you very seriously run the risk of not achieving your overall goal. These are a list, and it's the same list, or similar to the one that Bill put up earlier on, that the boiler efficiency and zone control, secondary heating, lighting, solar, draft lobby has been introduced now in the example, and also an energy efficient water pump. These are all seen as a basic requirement to achieve compliance. And if these are the basics, well, what scope do you have to improve on that, or to achieve it? You know, so it really makes it very clear that the figures that you see here, the 0.14, going well beyond the backstop, is a very real requirement. We need to be pushing our fabric first approach, and that has to be designed in from the outset. And as Bill rightly said, the air permeability that was shown in the 10 examples in the back of the regulatory impact analysis, which is available still online, I believe, very useful document, showed that all of the dwellings that complied were achieving an air permeability of around 5 or less, and that brings ventilation very seriously into question. So, you know, I can't emphasize that enough. Okay, the other interesting thing that's in Part L 2011 is a significant guidance piece on vapor control layers, which is very good from our perspective. Naturally, we're very keen to see this coming in. The more we insulate our buildings, the more attention we need to be paying to vapor control and moisture management in the fabric. The guidance suggests that you know, we need to manage convection losses and water vapor. This will prevent structural damage or you want to prevent structural damage and also the potential for reduced effectiveness of your insulation by having moisture move into the fabric. And an opening in the VCL is a potential source of moisture, or potential source of mold growth that can have disastrous results. So your buildings should really be assessed for risk according to the standards. And so we're seeing tools like WARFI becoming more utilised in the market. The further complexity, again, from a thermal bridging point of view, is that there are a number of ways, as Bill said again earlier on, to demonstrate compliance. But if we're going to achieve the overall target of 20% improvement, we really need to be looking at the better results there. The acceptable construction details gives a figure of 0.08, and actually that's very forgiving by the time you actually add all of the details in to place. Going the other route and using the tables that are in the back of Part L and calculating it yourself has the potential to give you a better result, but actually it doesn't give you all of the figures. It doesn't include thresholds, it doesn't include roof lights, it doesn't include chimneys and things. So potentially it might be misleading, and you need to look at these carefully. So we're still up here at 0.08, which puts again more emphasis back on U values and overall thermal performance. The alternative then is NSAI, as of last week, have introduced a new scheme for thermal modelling. You can check that out online. And this also applies to retrofit. If we're carrying out works that involve a material change or a change of use and indeed extensions, we need to be considering thermal bridging far more carefully on that side of things as well. So it's a real issue, and it's a complexity. There are tools out there that are relatively easy to get to grips with, but again, you need to be a certified thermal modeller to do that, or have the details approved by the NSAI. So when we look at retrofit as well, it can be challenging, and you need practical, adaptable solutions to achieve the results. Kevin was saying earlier on, buildability is a really key issue. You need quality solutions to pay attention to the thermal bridging, have continuity of your installation, and address the hard to treat buildings that are out there, and indeed the external finishes and so on. All of these things need to be addressed. This is far more than just a numbers game. So the solutions that we have out there in meeting this, it can be done. And again, Passive House has been a good example of that. We've seen it being carried out. This is a project down in Tullow, which very successfully integrated a number of key things. Kevin mentioned earlier on the use of a parge coat to seal the walls. This is what was carried out here. And again, continuity of installation using a depth dry lining system just carried right through with high performance glass wall and then vapor tight, intelligent air tightness membranes and effective wind tightness sealing to the outside with good rendering. And on this project, then they achieved an overall air tightness of 0.3. I mean, that is really going well beyond even the Passive House standard, and it just shows what can be achieved with good integration, with good joined-up thinking between the design team, between the client, between the suppliers, and between the contractors. We can achieve exceedingly good results. In fact, I got a message yesterday from another consultant I've been working with. He did a retrofit up in Belfast, and he achieved an air tightness result of 0.25 on a retrofit. Now, okay, the building was gutted, but it just shows what we can achieve when we set our mind to it. And okay, so as manufacturers, the way we see the keys to achieving this integration is through good technical information, good technical support. So that's what we're here to do. We have on-site demos, we've in-house technical services, and we have on-the-ground site specification teams and so on. We also reinforce the need then for practical training throughout the entire team. And this goes right through to your labourers, your electricians, everybody that has an impact on the overall quality of the build. So we offer training there in renovation, air tightness, insulation, and indeed the Weber NSAI contractors training as well. These are the brands, they're well known in the country. We've got a long-standing reputation here, so I don't need to reinforce that. Going back up to 75 years in this country. And then from a quality assurance point of view, offering the substantiated system performances and lifetime warranties for the products, the independently tested accreditation, and indeed the materials and workmanship guarantees for our systems. What we see is vitally important to achieving a good result. Our systems are also accredited and working on not just having the external, the first external accredited installation system, but also we're working now towards the first internal installation accredited systems. And some of the key issues there are to do with insulating correctly and proper moisture management, thermal bridging, all of these issues that are very, very critical and need proper attention. And with proper training, the entire industry can come very well together and have this joined up thinking to achieve an effective result. That's it. Thank you very much.